Now we are going to discuss about the PCR, most powerful test. Already discussed MP test uniformly, MP test. Now method of finding BCR. Method of finding BCR. Method of finding BCR. What is BCR? Best critical region. The test PCR is equal to best critical region. Critical region. Best critical region. A test which is performed, which is performed on the basis of on the basis of PCR, on the basis of BCR is called most powerful most powerful test. This is a the alternative definition of the MP test. PCR is the critical region, best critical region. Maximum power critical region is called BCR. Now to fix the alpha at low level, minimize the beta or maximize the 1 minus beta. The corresponding critical region is called best critical region. The corresponding test is called most powerful test. How to find the BCR? The method of finding BCR, that is very important. Method of finding BCR. For simple hypothesis against simple alternative hypothesis, the BCR of size alpha is found out using the Neyman-Pearson lemma. We have to find the BCR, simple hypothesis to simple alternative hypothesis. Using this Neyman-Pearson lemma, we can find out the BCR. This lemma provides the most powerful test of simple hypothesis against simple alternative hypothesis. H naught, simple hypothesis means H naught, theta is equal to theta naught versus alternative hypothesis H1, theta is equal to theta 1. Simple to simple concept. This theorem is known as Neyman-Pearson lemma. Neyman-Pearson lemma. This lemma is concerned with simple hypothesis and simple alternative hypothesis noted here. This is the importance of the lemma. Lemma is a part of the theorem. So there are 4 lemmas in the Neyman-Pearson theorem. So here we have to use only one lemma. Different situations are there. Simple to simple, simple to composite, composite to simple, composite to composite. There are 4 cases out there. Here, according to our syllabus, curriculum, for entrance examination point of view, so now we have to study the only simple to simple. Statement of lemma. NP lemma statement. Let k greater than 0 be a constant and W be a critical region of size alpha such that W is equal to X belongs to sample space S. X belongs to sample space S. Now, here is we consider the marginal function f of x comma under theta 1 dividing by f of x comma theta naught under h naught h1 This value, the ratio is value greater than k. K is any positive constant. This implies W is equal to L1 by L0 greater than K, and W bar is equal to L1 by L0 less than or equal to K. This is two important statements. W and W bar defined here. W is equal to find BCR uses this one, a shortcut formula. L1 by L0 greater than K gives so best critical region. You can also use W bar. Best practice is choose always W, where L0 and L1 are likelihood functions of the sample observations under H0 and H1. W is the most powerful critical region of size alpha for testing a simple hypothesis. H0 theta is equal to theta naught against simple alternative hypothesis. H1 theta is equal to theta 1. Theta is equal to theta 1. So this is the statement. Using this statement, we can able to find out the BCR. So, one example. Example 1. X follows Poisson lambda. X follows Poisson lambda. X follows Poisson lambda. Poisson parameter lambda. Now we have to find BCR. BCR is what? Now, first of all, here probability mass function, you know very well, e power minus lambda, lambda power x by x factorial. Likelihood function, e power minus n lambda, lambda power summation xi by pi xi factorial. Now, H naught. Lambda is equal to lambda naught against H1. Lambda is equal to lambda 1. Now, L naught, e power minus n lambda naught. So, replace lambda by lambda naught in likelihood function. Lambda naught whole power summation xi by pi xi factorial. L1 is equal to e power minus n lambda 1, lambda 1 power summation xi by pi xi factorial. Now, ratio, we consider the NP lemma ratio. L1 by L0 is greater than K. This is W. You should consider this one. Using NP lemma, the best critical region is given by L1 by L0 greater than K. Now, here is L1 is e power minus n lambda 1. lambda 1 power summation xi by pi xi factorial all dividing by e power minus n lambda naught power summation xi by pi xi factorial is greater than k. These two cancel. Implies e power minus n lambda. So now here is simplified format n lambda naught. So lambda 1 power, here is powers equal. Now here is base ratios here. Lambda 1 by lambda naught whole power summation xi is greater than k. Now here is apply logarithm both sides. Minus n lambda 1 plus n lambda naught log e base e1 plus summation xi into log lambda 1 minus log lambda naught is greater than log k. Greater than log k. Now here is n common factor lambda naught minus lambda 1 plus summation xi log lambda 1 minus log lambda naught is greater than log k. Now this value bringing to the side here. Now if case 1, if lambda naught is greater than lambda 1, lambda naught greater than lambda 1, summation, this difference is positive value, summation xi is minus log lambda naught minus log lambda 1 multiply with minus sign requirement. So bringing to this side here, log k minus n lambda naught minus lambda 1. So this is a positive difference here. So directly have to bring into this side. Now here multiply with minus sign both sides. Summation xi I is equal to 1 to n log lambda naught minus log lambda 1 is less than n lambda naught minus lambda 1 minus log k. Multiply with minus side both sides. Inequality also greater than is changed to less than. Now our requirement is BCR. BCR means here is function of sample observation, statistic. There is a sample statistic here. Less than n lambda naught minus lambda 1 minus log k dividing by log lambda naught minus log lambda 1. Summation xi I is equal to 1 to n less than this value is equal to c. Here, where c is equal to n, lambda naught, lambda 1 specified values minus log k. K is a constant value. If you know the k value, we can find out to c value. Log lambda naught minus log lambda 1. Therefore, BCR W is equal to, this is the best critical region. NP lemma provides, we applied NP lemma technique, we found BCR. So this is the best critical region. Using this best critical region, we can able to find out the size of the critical region, power of the test, and also type 2 error. I is equal to 1 to n, xi is less than c. Condition if lambda naught greater than lambda 1. So similarly, case 2. Similarly, case 2. Case 2. If lambda 1 is greater than lambda naught, then by applying the same procedure, BCR is equal to W is equal to summation xi, I is equal to 1 to n, is greater than C. Is greater than C. There are two BCRs. Lambda 1 is greater than lambda naught greater than lambda 1. There are two conditions, two cases. BCR is obtained. Now you can able to find out the alpha and beta and also 1 minus beta. So for nationwide universities, so we may expect this type of problems. For regional-wide, only concept is there. What is NP lemma? NP lemma provides what? BCR. This type of questions will be given in the regional-wide universities. For nationwide universities, so for Poisson distribution, what is the BCR? If lambda 1 is greater than lambda naught, your answer is summation xi. Summation xi is also follows Poisson distribution. You can able to find out the using this BCR, so alpha value, beta value, and also power of the test. One more example. X follows expo of parameter 1 by theta. Parameter theta. Find BCR. Find BCR. Here is H naught. Simple hypothesis. Theta is equal to theta naught versus H1. Theta is equal to theta 1. Likelihood function. Theta power n e power minus summation xi into theta. So likelihood function under H naught, theta power naught whole power n e power minus summation xi into theta naught. L1 is equal to theta 1 power n e power minus summation xi into theta 1. L1 by L naught is greater than K. Use NP lemma for BCR. Use NP lemma for BCR. L1 by L naught greater than K implies theta 1 power n e power minus summation xi into theta 1 dividing by theta naught power n e power minus summation xi into theta naught is greater than K. There is theta 1 by theta naught whole power n e power minus summation xi is a common one theta 1 plus minus is taken here. So here is plus, this is minus, theta naught is greater than k. Greater than k. Now apply logarithm both sides. N into log of theta 1 minus log of theta naught minus summation xi into theta 1 minus theta naught is greater than log k. Now minus here is case 1. Case 1. If theta naught greater than theta 1. The difference is positive, implies theta naught minus theta 1 is greater than 0. Now here n minus n multiply with minus, that is log theta naught minus log theta 1. Here multiply with minus, this is plus summation xi theta naught minus theta 1 is greater than log k. Summation xi theta naught minus theta 1 is greater than log k plus n into log theta naught minus log theta 1 summation xi I is equal to 1 to n is greater than log k plus n into log theta naught minus log theta 1 dividing by theta naught minus theta 1. Now summation xi I is equal to 1 to n is greater than c. Therefore, BCR in this case W is equal to summation xi function of sample observations is greater than c if theta naught greater than theta. So case 2. Case 2 is what? What is the case 2? If theta 1 is greater than theta naught, implies theta 1 minus theta naught is greater than 0. Similarly, apply the NP lemma. BCR is equal to W is equal to summation xi I is equal to 1 to n is less than c. C is what here? Constant value. C is equal to log k plus n into log theta naught minus log theta 1 by theta naught minus theta 1. If theta 1 is greater than theta naught, this is case 2. Poisson distribution is a discrete probability distribution. Exponential is a continuous probability distribution. Example 3. X follows n of u comma sigma square. So now here apply the NP lemma. We have to find the BCR of this normal distribution. So H naught is theta is equal to theta naught versus H1 is equal to theta is equal to theta 1. Theta is equal to theta 1. There are two cases here. Case 1, case 2. One is greater than theta naught, other is theta 1 is greater than theta naught, theta 1 is less than theta naught. There are two cases. Case 1, directly you have to remember this BCRs. If theta first one is theta 1 is greater than theta naught, then BCR BCR is W, that is equal to X bar is greater than C1. C1 is a constant where C1 is equal to sigma square by n. Sigma square is known log K by theta 1 minus theta naught plus theta 1 minus theta naught by 2. This is called C1. Case 2. If theta 1 less than theta naught, then BCR W is equal to X bar less than C1. X bar less than, there is theta 1 plus theta naught. X bar less than C1. C1 is same thing here. Sigma square by n log K by theta 1 minus theta naught plus theta 1 plus theta naught by 2. This is a BCR of normal distribution when sigma square is known. It's very, very important for the examination point of view. You can also find out the alpha and beta and also 1 minus beta. Now go to the another examples. To find alpha, beta and 1 minus beta. How measure alpha, beta, 1 minus beta for the given distributions. In this case, BCR is given, find out this one. So for typical model for nationwide universities, so we have to find the BCR. Using that BCR, we have to find alpha, beta, 1 minus beta. That is the nationwide universities examination model. But regional-wide university examination model, BCR is given, you have to find out alpha, beta, 1 minus beta. Only one is required. This is the two models are there. First model, BCR is given to find alpha, beta, 1 minus beta. Only one problem will be given in the examination. 1 mark weightage. For nationwide universities, so BCR is given, find out alpha, beta, 1 minus beta, one first model. Second model here, you have to find the BCR. Using that BCR, you have to find out the alpha, beta, 1 minus beta. That is 3 marks or 4 marks weightage. So this is a difference between nationwide universities and regional-wide universities. Now, problem 1, in this case, x follows uniform distribution 0, comma theta, h naught, theta is equal to 1 versus h1, theta is equal to 2. BCR is given, BCR W is given, that is 0.5 less than or equal to x. Single observation is considered. Only x is given means single observation consider. Single observation. Single observation is taken. In this case, what is alpha, what is beta, what is 1 minus beta? First of all, alpha. What is the formula here? X belongs to W under H naught. Alpha formula already explained. So now, probability of what is critical region? 0.5 less than or equal to x. 0.5 less than or equal to x. H naught is true here. H naught means here theta is equal to 1. But in this case, first prepare the probability function. F of x is equal to 1 by theta. 0 less than or equal to x less than or equal to theta. Now substitute theta. Now the PDF is f of x is equal to 1. 0 less than or equal to x less than or equal to 1. Our requirement 0.5 less than or equal to x. The lower value 0.5, upper value is equal to 1. The requirement is 0.5 less than or equal to x less than or equal to 1. Integral 0.5 to 1 f of x dx. So now 0.5 to 1. F of x is what? 1 dx. That is equal to x 0.5 to 1. The final result is 0.5. That is the alpha value. Level of significance. 1 minus 0.5, 0.5. To find beta, first of all, you have to take 1 minus beta. Don't directly calculate the beta. To calculate beta, you have to find out the W bar. Is the additional work. So no need to calculate the W bar. Using 1 minus beta, we can able to write the beta value also by using complementary techniques. 1 minus beta formula, probability of x belongs to W under H1. That is equal to probability of 0.5 less than or equal to x under H1 theta value is equal to 2. In this case, probability function is 1 by 2, 0 less than or equal to x less than or equal to 2. Now, 1 minus beta is equal to the probability of lower value 0.5, upper value is equal to less than or equal to 2. Upper value is 2. The probability function, probability density function is 1 by 2. Integral 0.5, apply the continuous random variable properties. 0.5 to 2 f of x to dx. To find this probability value, you have to use the conditional continuous probability, continuous random variable properties. Now integral a to b f of x dx, a value 0.5, b value 2. Now 0.5 to 2, f of x is equal to 1 by 2 px. 1 by 2 into x 0.5 to 2. The result is equal to 1 by 2. 2 minus 0.5, 1.5. The value is equal to 0.75, 3 by 4. Power of the test is 3 by 4. Now, probability of type 2 error. Type 2 error means beta. To get this one, complementary statement, 1 minus beta. That is 1 minus beta is 0.75. The result is 0.25. This is the procedure. When critical BCR is given, how calculate this alpha, beta, 1 minus beta? The continuous uniform distribution. Continuous uniform distribution. Next problem in this category, second problem. X follows exponential parameter theta h naught theta is equal to h naught theta is equal to 2 versus h1 against this null hypothesis. So theta is equal to 1. VCR is given W x greater than equal to 1. Single observation concept. In this case, alpha, probability of x belongs to W under H naught, probability of x greater than equal to 1 under H naught theta value 2. The corresponding probability density function is 2 into e power minus 2x, x greater than 0, greater than equal to 0. Alpha is equal to integral lower value 1, upper value infinity, f of x dx. 1 to infinity, f of x is 2 into 2 constant e power minus 2x dx. 2 into e power minus 2x by minus 2, 1 to infinity. 2 to cancel, e power minus infinity, e power minus 2 dividing by minus 1. So multiply e power minus infinity is e power, multiply with minus side, we get e power minus 2. The alpha value is e power minus 2 or 1 by e square. Very, very important problem. So 1 minus beta. Always you have to find out alpha and 1 minus beta, and also you have to write the beta value. Probability of x belongs to W under H1 is 2. X greater than equal to 1. X greater than or equal to 1. Given beta value is 1. The corresponding probability density function f of x equal to e power minus x, x greater than or equal to 0. 1 minus beta is equal to integral 1 to infinity f of x dx is equal to integral 1 to infinity f of x is e power minus x dx, e power minus infinity e power minus 1 by minus 1. The result is e power minus 1. So beta value, type 2 error, 1 minus beta, that is equal to 1 minus e power minus 1. 1 minus 1 by e. The result, final result is e minus 1 by e. That is beta value. First problem, X follows continuous uniform distribution. Second problem, X follows exponential distribution. These two are very, very important for examination. Third one, third example, X follows binomial distribution n comma p. Find alpha beta 1 minus beta. Here h naught is equal to p is equal to half. H1 is equal to p is equal to 3 by 4. Here, coin is tossed 5 times. Coin is tossed 5 times. And H naught is rejected. H naught is rejected if more than 3 heads, more than 3 heads are obtained. More than 3 heads are obtained. That is the critical region. How can you say that it is critical region? A coin is tossed 5 times, H naught is rejected. What? If more than 3 heads are obtained. So this is statement. H naught reject means here, this is the sample space divided into two parts here, dichotomous classification. Both are disjoint. So this is W, this is W bar. So 5 coins, a coin is tossed 5 times means 32 samples here. 32 samples, 2 power 5. Total sample space divided into two parts. If more than 3 heads, means here 4 heads, 5 heads. 4 heads means so 5C4. 5 heads means 5C5. 5C4 means 5. 5C5 means 1. 5 plus 1, 6. So here 6 heads, 6 cases are there. Out of 32, 6 cases in this interval from this point to this point. Remaining 26 cases in the W bar. So based on this statement, H naught is rejected. Your observed value falls in this area, falls in the W area, rejection region. H naught is rejected. In this case, H naught is rejected. To remember one point here, in the given problem, H naught is rejected based on the condition that is the critical region. Now, using this statement, we have to prepare the condition critical region. Now, X is called number of heads. X greater than 3, that is critical region. X greater than 3 is W. W bar is the X less than or equal to 3. In this case, either W bar can be used to find out our requirements alpha, beta like this. So, probability mass function of binomial distribution, NCX, P power X, Q power N minus X. Here, N minus X. Here, X is equal to 0, 1, 2, 3, 4, 5. N value 5. Now, alpha, probability of X belongs to W under H naught. Probability of W means what here? X greater than 3 based on the given statement. H naught means P value half. Here, P value unknown here. Using this null hypothesis, we assumed P value half. In this case, the probability function is equal to 5Cx, P value 1 by 2, whole power x, Q value also 1 by 2, whole power 5 minus x. Now, P is equal to half, Q is equal to also half. Symmetrical condition. After simplification, the probability function 5Cx into 1 by 2 whole power base equals powers adding minus x plus x cancel. The result is 5. Now, alpha is equal to x greater than 3 means what here? X equal to 4 plus x equal to 5. X equal to 5. X equal to 4 means x value 4, 5C4 plus phi c 5. Multiply with common constant value 1 by 2 whole power 5. Phi c for 5. Phi c 5. 1. 5 plus 1. 6. 6 by 32. The result is 3 by 16. That is alpha value. 3 by 16 is alpha value. Now, next here, we have to find out 1 minus beta or beta. Using this 1 minus beta, we can able to find out beta value. Probability of x belongs to W under H1, x greater than 3 based on the given statement. H1 is equal to, under H1, the p value is equal to, so 3 by 4. P value 3 by 4. P value 3 by 4. What about Q value? 1 by 4. 1 by 4. Now, in this case, probability function. So phi cx, p value 3 by 4 whole power x, q value 1 by 4 whole power 5 minus x. Now, 1 minus beta is equal to x greater than 3 means x equal to 4 plus x equal to 5. X equal to 4. Phi c4 3 by 4 whole power 4, 1 by 4 whole power 1 plus phi c5 3 by 4 whole power 5, 1 by 4 whole power 0. 5 minus 0, 5 minus 5, 0. Now, simplified. 1 minus beta is equal to. So now 3 by 4 whole power 4 is a common. So now here is phi c4 is what? 5. 5 by 4 plus phi c5 is 1 value. 3 by 4 whole power 4 is taken outside. Remaining part is 3 by 4. 3 power 4, 81 by 4 power 4, 256 into 5 plus 3, 8. 8 by 4. So, 8 ones are 8. There is a cancellation possible. Next, here is 2 times cancel. This is 128 times cancel. That is 81 by 128. That is 1 minus beta, power of the test. Power of the test is very important. So now beta, type 2 error, probability of type 2 error. Probability of type 2 error. 1 minus beta. 1 minus 81 by 128. That is 47 by 128. These 3 examples are very, very important for the examination point of view. Very important for the examination point of view. You remember, so you have to solve all these problems once again. Today, explained NP lemma, the importance of NP lemma. Several examples are noted here. Next, the last one, important definition is the important definition is unbiased test, unbiased critical region. The critical region W, and consequently the test based on it is said to be unbiased if the power of the test exceeds the size of the critical region. Power of the test 1 minus beta exceeds the size of the critical region. So the corresponding test is called unbiased test, and also unbiased the corresponding critical region also called unbiased critical region. Here is 1 minus beta here, probability of x belongs to W under H1, so is greater than equal to probability of x belongs to W under H0. Every most powerful or uniformly most powerful, already explained. This is simple to simple case, simple to composite case. So the difference of the MP and UMP is simple to simple, so simple to composite. So simple to composite advanced studies here. For every most powerful or uniformly most powerful critical region necessarily unbiased. Necessarily unbiased. Corresponding W's must be unbiased tests. So this is a testing of hypothesis topics are completed. So next go to the uh, level 1, level 2 problems of this testing of hypothesis.